Hello everyone, Dr. Chen here. So we're going to discuss the definition of work in this lecture video. So we move on to the chapter energy, work and energy, and we study conservation of energies. So let's start with the first concept, work. So work associated with force and displacement. So we apply a force on the object, and the object has a displacement of delta x under the work under the influence of this work. Then we calculate the work done by this force, a product of force times displacement. Now, unit for force is Newton. Unit for displacement is meter. So apparently the unit for work is Newton times meter. And Newton in SI unit is kilogram meter per second square multiply a meter. So SI unit of work is kilogram meter square over s second square. We give it a special name, joules. So 1 joule is 1 kilogram meter square per second square. Now this is the situation where the F, the force, and the displacement are in the same direction. If the force and the displacement are in the same direction, then it's simply F times displacement. Now the question is, what's happening if the force is not in the same direction as the displacement as shown in this situation? The force at the angle theta relative to the horizontal direction and the displacement is in the horizontal direction, then we should only calculate the work using the component of the force that is in the same direction of the displacement. So in this case, we should use x component of the F, which is F cosine theta, to calculate the work, and the work done in this case is F cosine theta times d. Now, so this is the definition of work when the force and the displacement is not in the same direction. So for example, if we hold a bucket of water, we move the water in the horizontal direction, then what would be the work done by the force that we hold in the basket pointing up? Then we need to examine what's the angle between this force and the displacement. Now if we hold this bucket, the force point right vertical up, displacement horizontal, so the angle between force and the displacement is 90 degrees. What is 90 degree? What is cosine 90 degree? Cosine 90 degree is 0. So this force doesn't do any work if the bucket of water is only have this displacement in the horizontal direction. Now if we look at this situation, we move a box from the ground up, then the force applied by us is pointing up. The displacement is pointing up. So our force is doing positive work because the angle between this force and displacement is 0. Cosine 0 gives us 1. Now on the other hand, gravity pointing down, displacement pointing up. See, this is displacement and this is gravity mg. So what's the angle between displacement and gravity? Is 180 degree, right? 180 degree. What is cosine 180 degree? Cosine 180 degree gives us -1, so gravity is doing negative work in this case. And so we find out now work can be 0, positive, or negative. It all depends on what's the angle between the force and the displacement. Now in this example, force is in this way, displacement in this way, this gives us positive work. But if the force and the displacement is 90 degrees, then the force doing 0 work. If the force is in the opposite direction of the displacement, then it's doing negative work. So to be more specific, how can we have 0 work? If there is no displacement, of course, it's always 0 work. Even if we have displacement, this displacement is not 0. But the force perpendicular to the displacement does no work. Now, if we have a weightlifter just holding this dumbbell, he's applying a force. The dumbbell is not moving, there's no displacement, is also going to be 0 work because there's no displacement. So if we want to work, we need 2 things. First, we have to have displacement. Second, the force has to have a component in the direction of the displacement. Now we need to think about what kind of work is done by the weightlifter. If the weightlifter lowers the barbell to the floor, so what is the force? What is the force applied by this weightlifter on the barbell? The force is pointing up, right? His force is pointing up, but displacement pointing down. So the angle between force and displacement is 180 degrees. Cosine 180 degrees gives us negative 1. The work done by this weightlifter in this situation is negative. Now this one is talking about another work. This one talks about the work done by barbell on the weightlifter's hand. In this case, the force from the barbell on his hand is pointing down, and the displacement of his hand is pointing down. So the angle between force and displacement is 0. So in this case, the barbell does positive work on the weightlifter's hand. But the force from the hand on the barbell is pointing up, something we discussed. Displacement is pointing down 180 degrees, so the weightlifter's hand is doing negative work on the barbell. Okay, so let's study this quiz together. We have a crane lower something. The crane moves at a constant speed. And then what is the work done by gravity and the work done by the tension of the table? So lowers, right? So displacement is pointing down. This is our displacement pointing down. This is gravity mg, and this is tension pointing up. So the angle between displacement and gravity is 0. So gravity should be doing positive work. Wrong, because gravity has to do positive work. Tension. So displacement pointing down, tension pointing up, angle between them is 180 degrees. So do you think the tension is going to do positive work or negative work? Cosine 180 degrees, negative 1, right? So tension should be doing negative work. Answer is E. Okay. We want to find out the work done when the traveler is putting a suitcase. The force magnitude is 45 Newton. The angle is 50 degrees. The displacement is 75. Then we just apply the equation, which is the definition of work. Force times cosine angle between force and displacement. Displacement, plugging all the numbers. Force is 45 degrees. Angle is 50 degrees. Displacement is 75 meters. And we found the work done by this force is 2,170 joules. Okay, another example. The truck is accelerating with acceleration 1.5 meters per second square. The crate is 120 kilograms. So it doesn't sleep, so it go with the truck. The displacement is 65 meters. What is the total work done on the crate by all the forces acting? So we need to draw free body diagram. What are the forces acting on the crate? We have weight, of course. Then we have normal force. And if we apply Newton's first law, the net force is 0. Net force in y direction is 0. We should have normal force equals weight. And then we have friction. What is friction? If we look at this crate, friction is the only force acting on the crate in the horizontal direction, and the crate has acceleration 1.5 because it moves with truck. So we can actually calculate friction, which is the net force on the crate in the x direction. It should equals to its mass times its acceleration in x direction. So friction is simply 120 kilograms times 1.5 meters per second square, which should give us 180 Newton, right? So it's 180 Newton. Okay. Now we need to find out the work done by the three forces on the crate. So let's calculate the work done by the normal force. This is normal force. Normal force pointing up, displacement horizontal. What's the angle between normal force and displacement? 90 degrees, right? So cosine 90 degrees give us 0, so normal force doesn't do any work. Can we do the same thing? Gravity, weight, pointing down, displacement horizontal. What's the angle between weight and the displacement? 90 degrees, cosine 90 degrees, 0. So neither normal force nor weight do any work in this question. Now we need to calculate what's the work done by friction. What's the direction of friction? Actually, friction is in this direction in this case. Static friction, and we know it's static friction because the crate doesn't sleep on the truck. And we have already calculated friction is the only force in the horizontal direction, so should be equals to m times a. So give us 180 Newton. And the work done by friction would be friction times displacement times cosine angle between Fs and this displacement, which is 0. Everything together, we know the work done by friction is a positive work, 1.2 times 10 to the 4th joules. You see, actually static friction, it is possible for static friction to do positive work for us. But here is the conclusion. Kinetic friction always does negative work, but static friction, it is possible for static friction to do positive work.